we have the graph of y equals to x squared once again. This is from desmos.com. And we wish to approximate the area under the curve from x equals to 0 to x equals to 4 once again. So we wish to estimate this area. So area under the graph of y equals to x squared from x equals to 0 to x equals to 4. This is what we want to approximate. And I already made a video of approximating this area using left and right Riemann sum, and I'll include the video in the description. And you can also click, hopefully you see this circle with I popping up right here. If you click it, you can go to the video about the left and right Riemann sum. In this video, we are going to explore approximating this area using midpoint and trapezoids and trapezoids. Let's start with the midpoint. For the first interval, that's our first one, that's our second one, that's our third one, that's our fourth one. Each of them has length of 1 because the entire thing has length of 4, and we are using 4 rectangles. Let's say we are using 4 rectangles. If you are using 8 rectangles, then each rectangle is going to have width of 1/2. But in this case, we are using 4 for simplicity. Okay? So we are picking the midpoint and we are drawing out the rectangle. So that's the midpoint, and that's going to be the height. So the area is going to look something like this. The rectangle is going to look something like this. For the second one, that's going to be the height. So the rectangle is going to look something like this. For the third one, it's going to look, if I can get it, it's going to look something like this. For the last one, the rectangle is going to look something like this. All you're doing, you're finding the midpoint of each interval, you're going up to the point it's hitting the curve, and that's going to be the height of your curve and your height of the rectangle, and you already know the width of rectangle to be 1, so you can just draw it out. Now, what's the area of the individual rectangle? For the first one, the width is 1. What's the height? Height is what you get when you plug 0.5 into our function. So 0.5 squared gets you 0.25, and since you're multiplying that by 1 to get the area is 0.25. For the next one, the width is 1 once again. So the height is going to be the same as area in our case, because height times 1 is going to get us area, or just the height. So in our case, because the width of each interval was 1, we can just find the height, and that's going to be the area of the rectangle. So for this one, you're plugging 1.5 into our function to get the area of the rectangle. And what's 1.5? 1.5 squared. And I made a video about how to quickly square numbers that end with 5, and you may also see another eye popping up on top of your video. You can click it to go to the video that I talk about 1.5 squared, 2.5 squared, and how to quickly do it in your head. Actually, let me kind of show you. For 1.5 squared, you're going to start with this, and you're going to add 1 to this, which is 2. And you're going to multiply this out. What's 2 times 1? That's 2. And you are always going to end with 25. And since we got, and that's our answer. And since we got a decimal point and we have to move it twice, our decimal point is going to go right there. So the area is 2.25. The area is 2.25. Next one, we are plugging in 2.5 to get the area of our rectangle. So 2.5 squared, add 1 to this number, which gets you 3. 3 times 2 gets you 6, end with 25, and decimal point is going to go there. So the area is 6.25. For the next one, you're doing 3.5 squared. 3 plus 1 is 4. Multiply them, get you 12. And you're going to put 25, and decimal point goes there. So the area is 12.25. So let's add them up. Our approximation of the area is about 0.25 plus 2.25 plus 6.25 plus 12.25. What do we get when we add up this number? Let's just look at the integer. 2 plus 6 plus 12 gets you 8 plus 12, or 20. and you got 4 0.25, which is 1. So our approximation is 21. And in fact, I'm later going to prove it to you in later video. The actual area is equal to 21.3 repeating. So this approximation is extremely close to the actual area. Now let's try to use trapezoids to approximate the area, and maybe you're seeing another eye popping up, and you can click this to go to the video telling you how to derive, how we can intuitively prove the area of a trapezoid. And hopefully you know it by now, but if you want to know how we get the formula, you can click this eye to go to the video. The area of a trapezoid with height of h and bases base 1 and base 2 is base 1 plus base 2 times height divided by 2. So let's try to use it. Our first trapezoid is actually a triangle going like this. Our next trapezoid looks like this. Our next trapezoid looks like this. Our next trapezoid looks like this. And all of them has height of 1. Now let's look at their base lengths. For the first trapezoid, or in this case triangle, the area is going to be 1 times what you get when you plug in 1, which is 1. 1 times 1 over 2, or 1/2. So that's the area for the first one. Let's look at the second one. This length is 1. This length is 2 squared, or 4. So the area is 1 plus 4 times 1 over 2, or 5 over 2. So that's our area for the next one. For the next one of the base is 4, another one is 9, 3 squared. So 4 plus 9 divided by 2, or 13 over 2. And for the last one, we have base of 9 and 16, add them up, divide by 2, 25 over 2. So in this case, our approximation for the area, not area is going to be 1/2 plus 5 over 2 plus 13 over 2 plus 23 over 2, which gets us 1 plus 5 is 6, 6 plus 13 is 19, 19 plus 23 is 42, divided by 2, or 21. We actually got the same approximation as the one we used for midpoint, and this is not always going to be the case. In this case, it turned out to be. And again, 21 is a very close approximation because the actual area under the curve, as we are going to prove it in later video, is going to be 21.333 and so on.